Let's talk about how to graph a logarithm. First, let's look at the graph of an exponential function, like f of x equals 2 to the power of x, because the two functions are inverses of one another. First of all, the graph of 2 to the x is we see the exponent gets negative, the numbers or the outcomes get small, or closer and closer to 0. That approaches what we call an asymptote. An asymptote is a barrier where the graph does not touch or cross. On this one, we approach closer and closer to 0. This is called our asymptote. So we have an asymptote at 0. Our function is at, let's just pick a couple of easy points to graph. No need doing anything hard. 0, 1, 1, 2 will be sufficient. 0, 1, and 1, 2. The numbers are very small as you go negative, or very, very, very close to 0. And as you approach 0, it starts to climb quite rapidly. A logarithm is the inverse of an exponential. It tells me what the exponent is. So it too has an asymptote. We can see over here that as we put in smaller and smaller numbers, we get more negative. So I can't put in 0, or I can't put in anything smaller than that, or anything negative as my input, because the outcome could never be negative from the exponential. Therefore, it also has an asymptote at x equals 0. And just like we did before, we'll graph just a couple of points, just the easy ones here. 1, 0, and 2, 1. So this one has an asymptote at x equals 0. And we're going to graph a couple of easy points. 1, 0, and 2, 1. And we can see that these two functions are just a reflection of each other over the line y equals x. And all inverses do that. They're a reflection of one another. Now let's look at the transformation of a logarithm. If there are parentheses in the log, the h value will shift the function either to the left or to the right. A plus h value will go to the left. A minus h value will go to the right. Your k value will go up or down. A plus k will go up, and a minus k will go down. An a value in front will be the product. You'll multiply the product of whatever the outcome is for a given x value. Apply that before you add or subtract the k value, but after you figured out your left or right shift. Okay, let's look at an example of this. Here we go. Okay, when graphing, I always like to start with, even though these 2 points aren't going to be on this particular graph, they help me know where to start from when I start moving things left, right, and up and down. I always start with 1, 0, and the base, 1. In this case, the base is 4. We can see that the base here is 4. So when I put in 4, I'll get 1. Now again, these 2 points are not on this particular graph, but they give me a starting point when I start shifting left, right, up, or down. 1, 0, and 4, 1. The asymptote for this particular graph will be the h value, or in this case it's -3. We can't put 0 or negatives into a log. They're just not defined. Therefore, if you put -3 in for x, -3 plus 3 would give me 0, and I can't put 0 or negatives into a log. So that's our vertical asymptote. We know we have a vertical asymptote at x equals -3. Our graph is going to shift 3 units to the left and 4 units up. So my 2 dots that are blue get shifted 3 units left and 4 units up. 3 units left, 4 units up. 3 units left, 4 up. The graph follows the asymptote up. We hit our 2 points and off to the right.